Hello everyone, my name is Nanda. I'm a blood and cancer doctor by profession, uh, and now I turned into Dr. Compost because I'll tell you why. And today we want to talk about life. Yeah, we are all living beings, and that's one of the most precious things on this planet is life. And life starts in the soil. Most of us, at least I, until recently, did not realize that life starts in the soil. And when I realized, it really piqued my interest, and I always believe life supports life. Uh, So that's one of the concepts that I want to bring forth in this lecture. So when I say what do you mean by life? It's actually living organisms, the way we define living organisms, like in biology. Yeah. So the biology is what provides nutrients to the plants. Most of us think it is fertilizer that provides the nitrogen, phosphorus, potassium, because that's what we've been taught. That's our belief system. But I can easily disprove that in 1 minute. Like if you go out and you see a mountain and there's these huge trees with lots of biomass, lots of green leaves, lots of flowers, seeds, fruits, lots of, life. So who is putting fertilizer there? Where are they getting the nitrogen from and phosphorus and potassium from? They make huge amounts of biomass compared to our farmlands. So then we have to ask the question, then what's going on? Why can't we use the same thing to farm? And actually, 100 years ago or before, that's how farming was done. There was no chemicals. There was no fertilizer. There is no pesticides. There is no insecticides. There is no fungicides. There was no chemicals. So what has happened is our perspective has changed, and we've been taught that this is the only way it works, and that's what is the problem. So today my main goal is to disprove that and hopefully find a better way to grow our plants and nourish ourselves. So my main goal is, how can we nourish ourselves? I mean, if we can nourish ourselves without life in the soil, and that's okay, but I do not believe that's possible. So let's get started. So how do we check for biology in the soil? I'll just play a video. If you take any soil sample and then put it and dilute it, so I got 3 ml of water here, and then this is my compost that I picked up this morning, and I'm gonna put a bit of compost in here to make it 4 ml. So I'm doing volume displacement basically. You know how much I put, not even a pinch. And then I'm gonna make it to 5 ml, so it's easy for calculations if you are measuring the quantities. And then I'm gonna shake for 30 seconds, and it's gonna form this nice rich brown color. I'm gonna let it set for like 10 seconds, and I'm gonna take a drop out of this, put it on a slide, and look under microscope. And I'm going to look at 40x, 100x, and 400x. That's the magnification. And this is what we find. I want to mute it so that is the fungal ball. These are microaggregates. This is a fungal strand. I don't know if you can see that. This is a fungal strand, and all these small dots, they are all bacteria. So you can already see there is fungus, there is bacteria, and go ahead.
What kind of fungus?
Good question. I don't know, but there is beneficial fungus and there is harmful fungus, and there is a way to tell which one is beneficial, which one is harmful based on morphology. So that's a whole another big section that I go for training. Yeah. So I saw a series on Netflix, like fungus, something on fungus. I don't know. Krish, do you remember the name of that show? Uh, and they said there are at least 1 million species of fungi in the soil and approximately 5 million species of bacteria and thousands of species of nematodes and stuff. Yeah. So the way we say this is a beneficial fungus is if it's at least 2 to 3 micron or more in thickness, and if they have septa. Septa means separations, and if their color is different than the background color. See, this one is more brownish, this fungal strand. So I would consider that as a beneficial fungus. And you can see a nematode. So we can find a lot of stuff here, biology. And then do you see all the movement here?
Yeah.
Some of these are all bacteria.
Yeah, you can see them.
And you can, I also saw a couple of protozoa, like flagellates. They zip around, like this thing here.
Yeah.
You see that moving here and here? And some of them, I can even see they are dividing, the bacteria are actively dividing. Yeah. And there's millions of bacteria in one small ml. So it's like there's a whole set of life in this tiny bit. So we want to bring this back to the soil. Now, you had a question.
How magnified is this?
This one should be 100x. 100x.
It says
I will
1.
show you 400x magnification also in a little bit, quickly zoomed in. Yeah. So basically we can also quantify based on dilution and counting the number of bacteria and how many fields of view, what is the field of view and all that stuff. So we can do all that. Today I just wanted to give basic background as to why biology is so important. So now let's see how biology works and why biology works. Yeah. So I have a thing for that. So how does life work in the soil? So we have plants. You know, plants use sunlight, carbon dioxide and water to make photosynthesis, and they make sugars. And those sugars, you would think the plant would use it for itself, but in reality it is proven 50 to 70% of what the plant synthesizes is pumped back into the soil and released as exudates. And plants release not only exudates in the soil, but even in the leaves and the bark. But that's much less compared to what they secrete into the soil. You know why they do that? Anybody take a guess? Why do they make all these carbohydrates and food and
To protect their home.
to protect their home?
Yeah, feed the nematodes and stuff.
So they feed. What do they feed? The bacteria. So the plants exude all these nutrition to feed the bacteria and the fungi. So, for example, if they want, let's say, manganese, right? The plants can exude special sugars like cookies. Like my son, he likes Oreo cookies. So we're gonna serve Oreo cookies. So I know Krish is gonna come here. So same way, the bacteria that can chelate manganese in this nook or corner of this specific plant, we call that niches, will be exuded. So that bacteria comes and eats that exudate, and then also gets that manganese or magnesium in a soluble form and divide and multiply. It's not going to just give it to the plant. This is the most important thing one we need to realize. It's not just going to give it to the plant. What needs to happen for that magnesium to go into the plant is somebody has to come and chomp on that bacteria to release the juices. The juices will have the magnesium or molybdenum or any element for the plant to absorb. So it's a give and take situation. So they exude, they make fungi and then the bacteria, and to eat those, you'll get protozoa and you'll also get a nematode. Yeah? And then they nicely feed on these, and then they don't absorb every single bit of it. Like when we eat food, we don't absorb every single bit of it, we poop a lot. So same way, that's what happens, and we call that as soil food web and nutrient cycling. So for nutrient cycling to happen, these big guys are very important. The nematodes, the protozoa, the microarthropods, they are very important. And then the plant gets what it needs. So this is how nutrient cycling works in short, basically. So we need to have all parts of the food web. Most of our compost when we buy from big box store, they don't have much biology. Forget about the big organisms, and they are nice and smooth looking. They are good for looks, but they don't do what's the job, and that's why compost has gotten a bad rap, unfortunately. And then one thing I wanted to add before I forget is this biology has to be aerobic. That's the most important thing. If it goes anaerobic, then you will get pathogenic bacteria. See, I mean, we all know there is pathogenic fungi, there is pathogenic bacteria, and there is root-feeding nematodes. Bad. These are bad. This will kill your crop like anything. So we don't want anything anaerobic. We want to support aerobic biology. So in a little bit, I'm going to show how I make compost using windrow turners, how I keep the temperatures, how I keep it aerobic, so all the good organisms are there. But I wanted to give a basic understanding as to what we were planning and what we were going in. So any questions about nutrient cycling or biology or aerobic versus anaerobic? Yes, sir.
Play into this.
So earthworms come on the bigger organisms and all this. So earthworms, when they also eat these, and actually
nematodes, they eat nematodes maybe? Microarthropods or arthropods?
Earthworms, all they do is they go bite, and squeeze and squish, and all the organisms that are inside, they will be crushed.
So
the juices will be absorbed, and then we get worm casts. We call it worm casts. Those worm casts are also very rich in biology because the gut of the earthworm has its own microbiome, and that microbiome is very good for soil.
So when you have, only way I was always able to gauge a soil was by the evidence of earthworms. That was pretty much it. But I mean, if you have a lot, you have too many. How does that work out?
They all balance out each other, and I'm sure, things eat. And you had an answer for that, or?
Yeah, if the earthworms become too populated, they'll stop breeding and get smaller.
Gotcha.
There's control mechanisms, because if there is no food for the earthworms, they're going to automatically be controlled. But earthworms is a good sign.
Okay.
But since you mentioned earthworm, now so a lot of people ask, okay, this is all good, I agree to everything you say, but how are you going to do this in 100 acres without using chemicals? It's a challenge, there's no question, which is what got me into this. Is, okay, I mean, we know the science, how are we going to put it to use? If you till, right, or if you run a big heavy equipment, which of these are the most susceptible to dying, you think? The bacteria, fungi, the nematodes, or protozoa?
Smaller. No? Bigger
ones, right?
ones?
Because the bigger ones are so easy to kill.
Yeah, gotcha. Yeah.
And not only that, look at this fungus strand. It's like a nice thread, right? And you till, fungus is shredded. So our soils are completely bacterially dominant. And there's nothing for them to eat. So they just eat, divide,
Divide.
make
Yes,
the
yes.
conditions anaerobic.
Anaerobic.
And then bad pathogens come, bacterial diseases come, fungal diseases come, root feeding nematodes come, and then you have to spray things to kill these.
That's what they keep doing. Yeah.
And then what happens when you spray
Yeah.
chemicals? These are going to be even more dead.
It's over and over again, every year.
So how do we restore life in the soil? So that's my goal. So that way, that life supports plant life, and the plant support human life. And nowadays we have lots of studies in cancer where your microbiome determines what cancer you're going to get. So where do we get our microbiome? From the food. You would think your food is sterile. I'm sorry to say, it is no way. If it is sterile, then
You are
it's
dead.
not good. It's bad because it's not providing nutrition. It's not providing biology.
Nutrient dense.
Now that we are talking about nutrition, let me say real quick something that I really want to spread the word. Now, let's say we eat this plant, right? And approximately in the periodic table, we need like 40 elements. Humans, for all the enzymatic processes that happen in the mitochondria, in gut, in brain, in the heart, every place. How are you going to get those elements if they are not in the plant?
Take a pill.
I know.
Isn't that
But
the answer
how-
nowadays? Take a pill?
But even the pill,
Yeah.
how do you know it is in a form
You
that can be
don't.
absorbed and assimilated by humans? It's not.
You don't.
So, my question is, how can the plant get that molybdenum or manganese or zinc if it is not in a soluble form in the soil? It cannot. It can only get what we as farmers, after killing all the biology, put over there, like NPK ratios and stuff. I'm not a farmer, so I'm not very good at it. But here is the truth. The truth is, a handful of soil has enough micro minerals and rare elements for 1 acre of farmland. But the plant cannot absorb it. The plant can only absorb it in a salt form in the way it absorbs. Like if I give you a ton of iron and somehow you had a gastric bypass surgery and your duodenum, that small part is cut, you will not be able to absorb iron. You will not. Even if I give you tons of iron. Because I'm a blood doctor, I give IV iron so many times, gastric bypass, and if you take chronically antacids, you need the right pH. So who is going to provide all that pH? The biology does that for the plant. So if you want nutrient dense food, starts with biology in the.
So,
So yes, a lot of people are labeling everything as organic nowadays, but that doesn't mean it is nutrient dense. Only thing it means that they have certain list of chemicals that they didn't use and certain list of chemicals that they can use. But for me, biologically grown new food is what's going to get nutrition into us. Same thing if the cow eats this or if the pig eats this grain, corn or whatever that's grown using chemicals, it's not going to have any nutrition. So it is the lack of nutrient density and chemicals that is causing trouble. All this while, before understanding the biology, I always used to think that it is the chemicals that is a problem, but I'm now beginning to think almost 50-50 is lack of nutrition is also a problem.
Yeah.
Any questions? Okay, so now let's move
he
on
has
to the-
one.
Yes.
If you provide plants or an organic material, won't bacteria gradually come and then the
Yes.
fungus and then it'll just keep going upwards?
We can, but it's going to take a while,
Yeah.
right? It's going to take a long time. And who has that much time? 100 acre, 1,000 acres of farming, he's not going to just put organic matter and hope for all the biology to come. So that is where composting comes in place, in my opinion. So let me show my composting operation now that we understand basics of biology and all that stuff. So what we do is, All over the county. They can come and drop it off for free. You see all these big piles of wood and things, and it also already comes in a nice cut form, so we are good. We pile it up in windrows, around like 10 foot wide, 7 foot tall. Yeah? And then look at all the. Otherwise, all that material would have gone in a landfill.
Yeah. Oh yeah.
So it's like we are trying to use that to make gold. You know, that's what I feel. And then we line it up, and
But you don't add anything to it, right?
we don't add anything.
You
Is
don't
there
have to.
already a lot of fungus growing in there?
Not a lot because you know it's pretty like fresh material.
Oh.
Yeah. So you see the string here. You can see the string here. Yeah. We wanted it to be straight.
Oh, I see. Oh my gosh.
Well,
Wow.
it helps.
I wanted you to see the windrow. So this windrow can go for a long distance, how much ever we want. Now, if you see, this one is compacted land. So we use the same technology they use in airports under the runway. What they do, we did the same thing. I use lime kill dust in a specific quantity to make it hard like a
Yeah,
rock.
yeah.
The reason to do that is when you pour water into this for the biology to work, we want this to be rock hard,
Yeah.
so that way it doesn't get all slushy and muddy and go anaerobic. Again, if there is two things that I wanted to say in this thing is biology, aerobic. Biology, aerobic. Those are the two words, take-home words. If from this lecture is, we want biology, we want it to be aerobic. But not here. Here we want it rock hard, so that way water doesn't get all
Exactly.
locked up. And then we put 3 feet of wood chips because that's the carbon. And then we have hay bales. I don't know if you can see the hay bales. We put 2 feet of hay bales on top, and then we put 10% of manure.
Wow.
So manure, a lot of farmers around here, like almost 95% of the farmers, they use manure, let it sit for a year or two, and then use it
Yes.
as compost, and they label it as compost. But if you think about it, manure is all anaerobic because it's coming from the gut. It has not had time to have all the aerobic organisms come in and do their job. So it's very important. We need to educate our farmers that that's not the best. It may be okay, but it's not the best.
That's what they used for centuries around there.
Yeah.
Yes,
Oh,
Yeah,
but
that's,
even in India, I did some research.
Yeah.
They did use cow manure
yeah.
to make, but they had a process to it.
Yeah.
They would add different things and keep it in a certain way before they actually put it on land. Nowadays, it's just make a pile of manure, wait for a year or two, whenever you feel like, and just spread it.
Yeah.
But then you're destroying, and that's why our land is being destroyed, farmland. That's why we have to use chemicals. If manure was going to work so well, why do we use chemicals then? We don't have to, right?
I don't know much. I mean, that's a big question. Why bother? You know, why?
Because the
why
company's
pollute?
making money. What do you expect?
They
Monsanto and
they sell these farmers on
Right,
that. That's
of
what they do,
course.
and they spend a lot of money selling
Yeah.
farmers on
100%,
that.
100%.
Right.
Yeah.
And they make it just right, cheap enough
Yeah.
that they don't want to try anything else.
Right. You
So
got it.
yeah,
And
it's all
time.
economy.
And
so
time.
I understand.
Somebody's time.
That's why, what I do is I put the manure through the worms and then I get the casting.
Yes, yes, that's a good way of doing it because as the worms are chomping up on the manure, they put their biology into the castings. So that's a good way of doing it. But how much castings do we need for 100 acres? So I am into making this more commercially viable. You know, vermicompost is very good for backyard gardeners and the pots and stuff. So we also do compost extract. So I don't know if I have time, I'll show you our extraction equipment. But we can also use vermicastings for compost extraction. And also, I think vermicasts, I'm not sure they have that much nematodes. I think they have a lot of good biology, fungus and bacteria, but I'm not sure the higher things that eat these little ones to secrete, I'm not sure they are there, I don't know. We are planning to start a huge vermicasting facility. We have a 5-foot wide by 80-foot long continuous flow through worm bin right now. So I'm interested in both, you know.
Yeah.
But so this is how we do it, and then we come with a windrow turner.
Are those fishing worms by chance?
Yes, yes, they are. You can use them for fishing. I mean, you can use any worm for fishing.
Yeah, it's true.
They are called red wigglers. Typically,
Yeah,
that's
very
what
high dimensional
most studied.
visually.
So we come with this. It's called a compost windrow turner. This was our first time, so you know, I didn't even know that I have to stand way back before I get like, you know.
Well, let me ask this: what effect does the antibiotics they're giving their animals, which are a requirement, I'm guessing nowadays?
On the manure?
Yeah, what effect does it have upon their manure and stuff?
It does. It does. There's no question.
All the chemicals, any chemicals.
Yes.
Yeah.
Yeah.
And the water.
I mean, when we collect manure,
Uh-huh.
right? We ask the farmer, hey, did you feed just in the last
Oh, yeah.
few days, so that way it's not excreted.
Yeah.
But here is what I plan to do. Oh, it's over. I'll answer that question in a little bit. Is once I have established biology that I have shown you, and I have some more videos that I can share, I am going to use those extracts to put it back in the new windrows.
Uh-huh.
So that way, I am multiplying what I want rather than what is coming in the manure. Manure is just to kickstart the whole thing.
Well, didn't you say it was you put 10%?
10%. That is to kickstart the process
Right,
of
I got
biology
you.
and
Yeah,
division.
yeah.
Yes.
Okay, good.
So if you see, this is so clumped up on this side
Uh-huh.
versus this is nice and fluffy. It makes it more aerated and mixes up.
You get that oxygen in
But
there.
if we don't have that, turner, it's very difficult to do it with pitchfork. I did that 3 years ago, and I spent a lot of energy on that. You had a question?
Why are you turning it? What does that do?
So basically it mixes up. So the wood chips, hay, and manure have to be nicely mixed and aerated.
Is that the
And-
first thing you do?
Yes,
Okay.
that's the first thing. Because if you think about it, if I do it at the end,
Yeah, then you'd get rid of the.
everything would be dead.
Nematodes are gone.
Yes, nematodes and fungi is gone. Yes, 100%.
But
You're smart, you know.
Yeah.
He's good. I like him.
you have to have oxygen though.
And oxygen.
They all,
and,
all these
and not only that, we have a water tank that comes and sprays. We need 50% moisture. So 50%, how do I know? When I squeeze, it should form a clump, but it shouldn't have exude water. So biology needs water, oxygen, and organic matter. So that's what we do. And so what else? And then we use thermometer to measure the temperature. Over here, it has reached like what, 145. And ours is a class 3 composting facility. And then there are rules and regulations that it has to reach 131 or above for 3 days for us to kill the weed seeds. Because when I'm getting hay, I don't want to spread weed seeds, so those have to be killed.
Yeah.
And also higher temperatures, at this temperature, anaerobic biology is not able to survive. So I'm giving a way for aerobic biology to develop by using heat. And the way this heat comes up is biology. Actually, when every bacteria cell divides 1 to 2, it is actively metabolizing, right? That metabolism releases heat. And I believe if 1 million bacteria divide at the same time, I think it increases the temperature by like 0.1. So for 1 degree increase,
Yeah.
you need 10 million bacterial divisions.
Yeah.
But that's not a lot. You see in this much, how many
Oh,
bacteria
yeah.
are there?
Yeah.
So even in the bitterest of winters, you can still reach 130. All you have to do is you just increase the amount of manure or increase the amount of hay. And then we turn it 3 times total. That's the requirement, because the center will come out when you are turning and the out will come inside, and you have to rotate it. So each part of that windrow has gone through the core, which is the hottest part and kills the weed seeds and kills bad biology. So this is very important part of the whole thing. And then we can look at some videos probably. There's some cool videos. Now this one you can see it's a bacterial feeder, and you can see it sucking up small bacteria. Right there.
Right
You see that?
there.
It's
Yeah.
gone. That small dot. And they eat millions and millions every day.
And that's kind of like a bat.
And then using the mouth parts, you can tell the difference between bacterial feeder, fungal feeder, root feeder, predatory nematode. Those are the big ones. So they all have to be there in the soil food web.
Wow, look at that.
And then you can see their gut, and there's so much we could do.
You know, have you considered
So this is
4-H?
100x. The previous one was 400x. You can see I zoomed out
Oh, yeah.
because it was moving fast.
Yeah.
Wow.
He's on caffeine.
And I think in this one, I saw a nematode, which one is a big one, was eating a fungus. See, look at that. It just
Wow.
sucked up the
Oh.
fungus
Oh.
like
Oh,
as from
okay.
a straw.
Yeah, wow.
So my point is, if there is a bacterial feeding nematode, it means there is enough bacteria. If there is a fungal feeding nematode, that means there is enough fungi. Otherwise they won't survive.
To balance.
So a lot of people, they go and then like they get hooked, stuck on the concept that how much fungus is there, how much fungus is there. The key thing is everything being in balance, and they are doing their job.
Isn't that something? What you see? Wow. Look at that. Oh my God.
Looks like an aardvark.
Yeah, something like that. Yeah, interesting stuff. This seems like something you should show to the 4-H locally. Have you considered that
Well, the high school.
before? Yeah.
Yeah, there's more biology here.
Yeah.
Things zooming around.
Wow.
Yeah. But these new farmers, they need to know this
Yeah.
stuff. They need to,
Well, you have to open your minds first.
Absolutely,
To
yeah.
absorb,
I bet they would.
Yeah.
My question be, how does this, how would it affect houseplants per se? Would it help houseplants or?
House plants?
Yeah.
Oh yes, absolutely.
So effectively, you could take a bag like that.
Yes.
And sell it for a houseplant. I mean, like that,
Yes.
like that.
That's usually.
100%.
That's all you would need for a houseplant.
Pretty much.
Yeah,
A handful,
right. But
And
they
then-
don't do that. I
Yeah.
mean, They
you know,
do their
That's
tin-
the
tin
market.
cans.
because most of the house plants, they have what? Peat moss
Yeah.
and coconut coir
I don't
and
know.
slow release fertilizer beads.
Yeah,
What happens is those slow release fertilizer beads are all salts. So if you just put it next to all that, that may kill this. So if you're putting for house plants, I would not put any fertilizer.
oh,
I wouldn't put fertilizer anywhere
Yeah.
because it will kill the biology. So if you're putting biology and again putting fertilizer or pesticides or whatever, you're like just defeating the purpose. Yes.
So how do you apply
the compost?
We can spread it. So if it is a 10-acre farm, right? We have manure spreaders, and then those just spread it.
Dry.
Yes. So how much do you need? You typically need 1 to 2 tons per acre. You don't need a lot. It's just 1 to 2 tons per acre, because the biology, if there is plant material there, it will just divide and spread. It's like making yogurt. You only need a teaspoon of
Yeah.
yogurt for a
I
whole
remember that,
ball
yeah.
to become yogurt, right?
Mhm.
If the right conditions are there. But if you just gonna spread it on bare land where there is nothing and let it dry, the biology is gonna die, right? Because if you remember, the biology needs the exudates from the plant to survive. So as long as there is some organic matter and you want to plant corn or soy, you spread the biology, the compost, and then you can do the regular stuff. So we recommend no-till and cover crops, which is why we recommend that.
So I'm doing them.
Because we need this part. The cover crop provides continuous nutrition to support, and then your annual crop you can harvest
Oh, I
bigger.
see, yeah.
So the cover crop and companion planting, very important.
Oh,
So that's why there is continuous
I see, yeah.
exudates supporting these. Even if you really believe you don't want to do it, it is still fine, because this biology will go dormant, and when you put the next years, it will come back.
Yeah. Cool.
Down, because not all of us have 100-acre farms. Some of
Yes.
us have tiny backyard gardens.
Yes.
So if we were making our own compost, I know a lot of people say you put your kitchen scraps and you
Yes.
put your lawn clippings and everything. How would the kitchen scraps fall under like your
Nitrogen.
Nitrogen, so, okay.
But they have to be turned, right?
Yes.
You cannot put a whole banana peel. You have to chop it, because it will have anaerobic pockets.
Yes.
That's why it stinks. If you come to my facility, it's like beautiful forest floor, no smell. Whereas if you put kitchen scraps and all, what happens is there is pockets of full of nitrogen, there is not much air. Most of them use those enclosed things to turn. We want aerobic. So two things if you have to take home: aerobic, biology. And we are missing aerobic. And that's why they are not successful and they give up. I have done it. The same amount, I can put it on one windrow and make the compost. But the equipment is expensive, and then you need a place. So that's why, as a community, we have to support each other. So, if you all come up with a plan where, hey, you know what? I have grass clippings. I'm gonna give you this big bag of grass clippings. I'll give you this much of compost. You give me the green part, I'll give you the compost. So there are so many things we could do. There's so many things we could do. And one of them, who is very into microscope and stuff, he can do the biology checking using the microscope, quantify and stuff. What has changed? Why is this way? Somebody is interested in vermicompost, they can study the vermicompost part. So we can easily have 100, 200 people involved in this. Let it be volunteers or anything, specific. Somebody wants to check temperatures, look at, check the temperatures in the window. Have they hit the temperatures, right temperatures? Mark the temperature. There's so many things that we can.
And is the pH important? The
Yes.
pH, yeah.
So
pH.
pH is automatic, right? We believe that the pH and everything will be managed accordingly. For example, our body's pH is what? 7.4 we say. But what is the pH in the stomach? Around 2. Because
It is.
we have acids, right? What is it in the intestine? More alkaline. So what I'm saying is, when an extension officer checks for pH, he's gonna take the thing, mix up everything, and say, oh, yours is acidic and alkaline. It has no meaning when each rootlet needs a different pH to absorb different mineral, and that provided by the bacteria again. The bacteria that secretes those glues, and the fungus that does the metabolism, they provide individual pH at each niche.
Gotcha.
You see, I mean, look at this. There is a million homes here. There is a lot of people don't like this big chunks, but this is a big home. Like we have big houses, and they have a different biology.
Big house.
Yeah.
You know, and this is a tiny home. Now look at this. This is actually, I think, is a fungal strand. So, actually, this morning when I was bagging compost, we were surprised. I was so happy to see that. Now look at all this mushrooms.
Oh, yeah, yeah, yep. Wow. My goodness.
This was this morning.
Are they edible?
No, I don't know. Maybe, but they are, you know. But
Right.
what I was saying was there is a lot of fungus. I was telling you our whenever there is bacterial dominance, there is more weeds. We call that successional. FB ratio and succession, and I'll show you a thing on that. So if the fungal to bacterial biomass is less than 0.01, that means it's pretty much dead soil. Anything less than 0.03, more weeds grow.
Yeah.
And as you hit close to 1, your grasses and corns grow. Corn and other crops, annuals. As you hit like 2, 5, and 10, your shrubs like peaches, apples, they grow very well. And then once the FB ratio is more than 10, in some of these old growth forests, the fungal to bacterial biomass is like 1,000. Then big trees and all, those are supported. And how the nutrient cycling works,
That's what's
I mean,
going
it's a PhD or, you know, a big course in itself to study each individual part of that. Yeah.
So that's why my fruit trees don't do too well because of the ground.
Yes.
Even though it should be,
Yes.
and it looks fine, and it looks
Yes.
pretty,
Yes.
they're just not, they don't produce any yields.
Yes. You have seen, you know, at my house, the fruit
Yeah.
trees is like
I
abundance.
know where to get the
abundance.
peaches now. I know where to steal the peaches, how's that?
Yes.
I know, it's something, it really is.